Okay, I had a couple really good questions about work coordinate systems and zeroing our part in PathPilot and also in the mill itself. For the mill, I have this turned on, reset. I have referenced the Z, the Y, and the X. Now, as far as where that actually references, remember in that PathPilot control, we have that isometric view that we've been calling the fish tank or the fish bowl. That fish tank, the top back left corner would be right here. And so you could imagine the depth of the fish tank is here and the rest of the fish tank is to the right here. And you can see our vise is kind of in the middle of that fish tank. I'm going to be taking our rough stock that has the 1.5 inch width, 3.6 inches long, and the Z depth of 0.5 inches, and I'm going to be putting it in our vise. Now our vise has a couple of parallels in here. A parallel is a precision ground piece of metal that has a very even side on here, and of course they are parallel on both edges. There's also one on the movable jaw. I'm putting this one at the fixed jaw and making sure that down in there's no chips that'll get underneath this parallel because I want it down on the surface of the vise. I've also deburred this part, and so there's no rough edges that'll cause it to stand up even slightly on one side. So what I'm going to do is I'm going to open up the vise a little bit. And I'm going to put our part in there. I like to work the part side to side to make sure I'm down solidly on that, and I also put a little bit of pressure downward as I start to tighten the vise. And once I get it a little bit in there, I want to give it a knock test. You want to hear it being nice and solid. You don't want to hear any looseness in there or any hollow sound. I'm going to tighten that down good and tight there. The next thing I'm going to do is I'm going to actually locate where the exact center is. Not just my Sharpie mark, but where the exact center of that part is. And the way that I'm going to do it is I'm going to be putting this tool into our spindle. This is called a Haimer probe. It's actually called a Haimer Zero Master. And if you watch the needle, you can see that as I push slightly on that plunger at the bottom, it moves. If I move to the side, it moves. If I push front and back, it moves. So it detects any movement, left, right, up, down, front, back. It has on here some readings, and these are in thousandths of an inch. So one full revolution is actually 50 thousandths of an inch. This ball on the end of the touch probe is 0.200 inches. In other words, it's 200 thou. So that means from the edge of the ball to the very center of the ball is 100 thou. 100 thou is 2 revolutions on here, and that'll become important in just a moment. I'm going to release this set screw collet, and I'm going to put the Haimer in. Now what I'm going to do is I'm going to use that to touch off on the left side of our part. I'm lowering down, I'm jogging this by hand with what's called our jog shuttle. I'm going to come up on the edge of the part. And I want to make sure that I'm low enough. Looks like I need to drop down a little bit in the Z direction. And I'm going to move that probe, or move the table actually. Oh, see the needle move? That's 1 revolution, so that's 50 thou. And I'm going to come over and I'm going to go 1 more revolution, and that will be a total of 100 thou. Now I can even dial this in and move very slowly. See how slowly that needle's moving? Right there, I am 100 thou over. So what I'm going to do is I'm going to go onto PathPilot, and I'm going to click 0 right here. I'm going to zero out our DRO. Then I'm going to come back over here, and I'm going to lift it off of that surface. I'm actually going to go back, come off it first, and I'm going to raise up in the Z direction. I'm going to go across in the X, And I'm going to drop down in the Z direction before touching off on this other side. And once again, I'm going to look for 2 full revolutions. I want to come down in the Z just a little bit. There we go. There's 1 revolution, coming up on 2. Right there, I'm 2 full revolutions over. Now let's go take a look at what we have. Here in our X direction, it says 3.5732. Remember, we were saying it was 3.6 inches long. Looks like it was just a touch short, 7/1007 inch short. I can deal with that. So what I'm gonna do now is I'm not gonna zero it here. What I'm gonna do instead is I'm gonna say take that value and divide by 2. So now it says 1.7866, which is exactly half of what we had before. What did I just do? Over here, if we look back at what we had, we set this edge as 0. And so when we measured all the way over to here, it was just under 3.6 inches. We can call it 3.6 inches for this discussion. Then we said, nope, call this value half of that. So this ends up being basically 1.8 over here, which means 0 is then 1.8 inches back, which is the center of our part. We're going to do a similar thing on the Y direction as well. I've gotten it right at 0 in the Y on the back side of the part. I'm going to come over here and I'm going to 0 it. Now, let's go to the front side of the part. There's 0 at the front side of the part right there. So what do I do here? Oh, it says it's in the negative direction. I don't care. Notice that it's about 1.5 inches from where it was before. I'm going to click on this and I'm going to say divide by 2. Enter. So now this location is known as negative 0.75 about. And lastly, we're going to do the Z. I'm going to come onto the top of the part. I've already measured this Haimer, and I know the distance from the mounting surface up here, which is where we measure all of our tools from, to the very center of that ball. I've already measured it, and it is 4.5701 inches. So now what I'm going to do is I'm going to lower down my 100th thou, just like I have before. And because I've already measured the length of this Haimer, then what I can do is I can now call this 4.5701. That's the length of this particular one. You would need to measure the Haimer that you're using with a height gauge. And I'm going to press enter. Now, whenever I put in a tool offset, it's going to know to take that value and add it to these positions to know where the absolute tip of the tool is. Let's talk about why we had to create a virtual origin in PathPilot, especially with the PathPilot HUB. I have the machine turned on here, and now I'm going to reference the Z, the Y, and the X axes. Okay, now it is referenced in all 3 axes. The reference point in our machine is actually the back left top corner of the fish tank that we've been talking about, which is the build envelope or the machining envelope here for our machine. If I were to program some tool paths using this location, that might actually tell the tool to cut a little over to the left or to cut a little towards the back, which is beyond the limits of the machine. So what I have to do is I have to create a false 0 point for my work because I don't have a part mounted in the virtual PathPilot. I don't have a vise there. I don't even have a mill there. I have to create a false location for it to start all its milling operations of, and the dimensions that we choose, moving over in the X 7 inches, moving forward in or backwards in the Y -3.75 and down in the Z 7.5, all of those measurements create a situation where we will have the tool located in the center of that entire build envelope.